Suppose that we want to reduce this total deformation. Suppose that total deformation is coming very more. We want to reduce this deformation. Suppose this is any plate where we have to use this in any of the appliances or anywhere, and we want to reduce its deformation. So the solution is that we have to just increase its thickness or cross section size from anywhere. Okay, now how to do this? Just close this model option, right click on this geometry option, and then click on edit geometry again. Now we can see the same figure here. Now in order to reduce the deformation here, we may change the parameter of this stress, like we can change its thickness from 20 to 30. This is done by consulting and by seeing the designing criteria and parameters, that what we can change, what is the resources that are available within ourselves, that if we can change the cross section size. Suppose we work to, now we can talk to our manufacturer, and from there we can consult that to whatever the parameters we can change. Or if the manufacturer will recommend you that you can change the various parameters, they only give you the deformation, that we must see that total deformation does not go beyond this parameter value. You may change any of the cross section. So it's up to us that what we can change. We can just change the cross section, we can increase the thickness, or we can change the material type. So here, if I'm going to increase the thickness, just we have to generate this. After doing this, just close the design model, again open this model window. It will take some time. And sometimes the model or process, if we do not refresh the model, our file get crashed. So no worry, just I'm going to explain about one more feature of analysis, that is, suppose we have made a geometry but this model screen is not opening. So we can just link this geometry to another static structure module also. Just drag and drag on any of the boxes, and just click on this geometry and drag to this geometry option. Here you can see share A3. A is this module and 3 is this portion. That just drag on this, and you may see the linkage here. This linkage resembles that the geometry that we have made here, the same geometry is being copied to this portion also. Okay, and just provide this feature also. So if we just check on this, just right click on the model and just click on edit option. Just wait for the progress. and it takes some time on loading the model window. And you can see that the same model appears in the new module of ANSYS Workbench. Okay, so whatever you have done this effort, the effort is not being lost anywhere. Suppose if this window is being get corrupted or not opening for any of the reason, you may just open another static structure option and just link on this geometry to the another geometry option so that we can copy this. Okay, now we will follow the same option. We will generate the mesh, right click on static structure, then click and apply force. The force we are going to apply on this edge, so we will select on the edge selection, click on the edge and then click on apply. We are taking the magnitude as 100 Newton and then changing the direction towards downward. Now the other phase, just we are right clicking on the static structure and going to fix support option. Just clicking on the face selection on and just clicking on the face and selecting on apply option. Okay. So we have given the same parameter that we have given earlier in that figure and then right click on this, go into solution, insert, deformation and total deformation. Just right click on solution again and just click on solve option. Now you can see here that the total deformation is being reduced here. That is 0.024784. As we have increased the thickness of this plate, the deformation is reduced here. Okay. So by the help of this only, we will just change the parameter and see here that our figure, our part is being fit with the assembled part or is going to be fit in the manufacturing part or not. Okay. Now, in order to add more reports, I have told you earlier that just right click on, go to strain option and then click on middle principle. Then again, right click on insert option, then go to stress option and then click on maximum shear stress and just right click on the solution option and click on evaluate all result option. So clicking on this, we can also see another parameters also. Okay. So is there any doubt
No, sir.
here? Okay. Now just moving further and till here I have I hope so that you are interested here. Now moving towards another part which is also very much helpful towards us, that is we can just generate a report also from this software, a typed report. Okay, first in this working window we can see here the geometry option is open below the screen. Above the graph window, the geometry option is open. We can print out this geometry. Just after that option, you can see your print preview. Just click on this option and we can see here that a page is being created here. It's written here total deformation, then subject, author, prepared for, and we can see here. So whatever figure we want, we have to just adjust that figure and then click on print preview option. We can see here that whatever we have adjusted the figure, the same design, the same direction, the figure is being previewed in this window. Okay, so if you want to print this, just click on print preview and above the outline window we see here print option, which means we can directly print out this part. So If the printer is connected, then we can print it. If it is not connected, then we can save it to PDF format. First option is here. And the next option is that we can click on this send to option, and there we can see three options. One is email recipient. As an attachment, we can just directly send this part to an email or move this part to Microsoft Word or PowerPoint. Just click on this MS Word option and we can see that the whole this page is being automatically moved to MS Word. You see here my MS Word has been opened, and here we can see the same part is being just copied here. Okay, now here we can make changes whatever we like, whatever we want to, if we want to add subject, we can add subject here. We can add here date, any comments. If you want to delete this comment option, we can also make changes here. Okay, and just we can adjust this figure, which means if we are preparing any report, any notes here, we can just directly copy and move this whole portion of the figure to MS Word, and from there we can cut, copy and place the figure wherever we want. Okay, just remember we cannot change this portion, okay, because it's in the form of image file. Okay, so we cannot change this portion. Okay, now same, if we want the report of middle principal elastic strain, just double click on it and you can see here static structural middle principal elastic strain. Just if you see that this portion of the figure is been overlapping here, just adjust this figure and then click on print preview view. If the figure is okay, then click on send to and click to MS Word or PowerPoint, and you can see here that static structural, here the second report is also open. That is in on the first page there is total deformation, and on the second page it's given middle principal elastic strain, and this figure can be straight away transferred to this. Okay, which means we can directly send this figure, whatever the figure is shown in this solution option. We are just double clicking on this to change the figure layout. I'm just double clicking on middle principal maximum share, and the figure has been changing, and we can directly export this figure to MS Word so that we can attach it with our report. Okay, moreover, if we select this total information option and below this print preview we can see here graph option, and below this graph option we are seeing here animation option. If we just play this animation, we can see that how the figure is being moving. We can see here that the portion where is the maximum deformation, we can see that the figure, the bar of plate is being moving downward direction. Okay, just stop this animation. If we increase the frame, we can see here the frame option. If we increase the frame size, we can see more smoothness in the movement of the figure. Okay, now if we are setting the time to 3 seconds or 4 seconds, then we can see here that the figure is being moving and taking some more time while seeing the animation. In 4 seconds, we can see that the figure is taking some more time also. Okay, so here we can animate our figure also in various aspects. Now, above the outline window, we can see some more options. This option is just to make our figure more visible, more attractive or eye-catching. First one is we can see here result. The result is on auto scale. Now, we can see here that on result section, the figure is slightly deformed here. The figure is slightly deformed here. If we just click on undeform option, we can see that figure is being now in its original shape. Okay. If we move to true scale, then the figure is deformed, but it's not so much visible to us, because if anybody there is a deformation of 0.02 mm, its movement is negligible. Okay, it's a very small step movement, and we cannot see the changes with our blank eye, naked eye. Okay, so this is the true scale. But as soon as we move below, that is 0.5 octo, we can see here the deformation. And as soon as we move to auto scale, more deformation occurs. Then 2 cross auto scale, and then 3 cross auto scale. So that this option is just given so that we can see that, yeah, deflection occurs. But in true scale, this much deflection does not occur. It's just the quality and feature of software that it is letting us to show that, yeah, if we are making us and fix and just giving a force here, then the deflection is going to occur this side. Okay, so here we can set our scale whatever way we want to show the deflection. Then beside this, there is one option which is known as the geometry option. By clicking it, there are some more options present, that is exterior or isosurface. If we move to isosurface option, we can just only see the surface of that geometry, nothing else. From where the parameter is going to change, we can just see that surface. Okay, so this is isosurface option. Then below is the option that is known as capped isosurface. Okay, so in capped isosurface, we can see only those options. Means if isosurface we want only see this option or this option, we can just move to capped isosurface, and whichever option we want to see on the screen, just we can move it by this. Okay, now in capped isosurface also some options are given. First one isosurface, then next is top cap isosurface. In this, if we want to see only some portion of figure, suppose we want to see the deflection of only this portion, up to this portion only, then we can just click on top capped isosurface, and just by the help of this range cursor, we can just increase or decrease the portion of this. Okay, but in animation part, from full figure the animation occurs, and it stops up to that portion. Okay, so this is top capped isosurface. Okay, and we also see that as we are moving inside, the portion is being slightly curved, changing to slightly curved. See here, as soon as we are moving inside, especially on this blue section, we see here that the bar portion is being slightly curved. This curve means that there is some blending or twisting movement that is being occurred inside its body because of the force that is applied on the edge. And this, since this phase is fixed, so stress is being generated at this portion itself. Okay, we can see here in this stress case, if we are just tap cap of surface, then we can see here that firstly the stretch is going to occur from this portion, from the from where we have fixed our surface, and then moving towards this. Okay, so we can just adjust this in order to make aware of any one that from where the stress is being, or where the figure is going to be break if we are using the parameter. Okay, so this is top capped isosurface. Beyond this is the bottom capped isosurface. This move from top to bottom, and from this the figure is moving from bottom to top. Okay, means if you want to see the changes from bottom side of our figure, then we use bottom. Or you may see here that from top cap of the surface, the figure varies from maximum parameter to minimum parameters, and from bottom, in bottom, the figure varies from minimum to maximum parameter. Okay, so this option is known as capped isosurface. If you don't want to see this option, just click on exterior option, and this is the previous and by default option that is being done here. So this is just to visualize our figure, our geometry, that how our geometry we want to demonstrate it. Suppose we want to just make aware that from where the breakage occurs, just click on this shear stress and just click on this option, show the breakage point here, and just click on print preview option. The same figure we can see here, and just click on send to and MS Word. Okay, now beside this, there we can see one more option, that is contours. Okay, just I'm going to select exterior options, and beside this geometry option we can see one more option, that is contours. Now what are these options? The color coding, the color parameters here is drawn, is also known as contours. Now if we select here on the contour option, if we select smooth contours, we can see here that no lining occurs, the figure becomes smooth here. If we select contour band, then the band occurs like previous one. If we select iso lines, then the figure colors remain same, and just the parameters lining part is in just appear here. Okay, so this linings is known as iso line. And if we select here solid fill, then no contour bands and no linings appears here. So these are just only settings. These only set the visuality of our figure, that how would like to visualize our figure in our report. So we can select smooth contours, okay, or contour bands. Now beside this, we can see here edges option. Okay, just click on this, and here we can see no wireframe or show undefined wireframe. So when we select on this option, we can see here that the figure has been deflected in this shape, but undefined figure is being here. So in order to make aware to anyone that deflection is occurring, we just, if we just move to no wireframe option, it's just looking that there is no deflection occurring in the figure. If we just ignore these parameters, this written part, we can see here that no deflection occurs. Okay, because the screen is just showing us that the figure is in straight direction. If we just take the print preview of this portion, and if we are ignoring these parameters, then we can not see any of the deflection that is being occurs. So to make aware of this, just click on show under deform shape, so that by the help of this wireframe we can make anyone or the viewer understand that the figure is in undeformed shape and the deformation is being going from this side. Moreover, if you want to show undeformed model, the same thing is being given, but the original model is being just provided or just shown on this highlighted portion. Okay, so we can show this setting, or we can just click on show elements. So the figure is being showed in the form of meshed portion, which means the meshing is occurred and the figure is shown in the form of elements. Okay, so whatever settings you may write, you can occur. Okay, beside this, there is one more option, that is graphics. Just click on these options and we can see the same parameters, same color codings in the form of vector graphics. We can see here, if I zoom out this, we can see here that arrow is being placed here in various colors, and these arrows are known as vector graphics, which means that first thing is that the deformation, the arrow is pointed downward, which means the deformation is occurring in this direction. With this vector graphics, we can get to know that the direction of the deformation is this direction, that is -5. Now we can just change the vectors to uniform vector or proportional vectors, whatever we like to here. In uniform vectors, we can see that the arrows, the vectors are in uniform plane. And if we are going to see the proportional vectors, we can see that the uplifting uprighting portion of arrow, as soon as we are moving towards the maximum deformation, the uplifting uprighting of the arrow is been increasing. So this is the proportion option and this is the uniform option. Plus, we can just increase the direction and size of the arrow. We can see here clearly, as soon as we have increased the size of the arrow here, we can clearly see that the difference between a proportional and uniform option of the arrow. See, this is proportional option and this is uniform option. Plus, here is one more option, that is element align and then grid align, which means that what will be the alignment of these arrow, whether they are going to aligned here by the element means whatever is the portion of this contour band, in that only proportional the arrow is being aligned. Means this contour band, this portion is in red color, so red color arrow will be aligned in this portion only, then orange color in this portion, yellow color in this portion, and so on. So this is element align. And if we don't want to align our arrow in element wise, then we can choose here grid align. Okay, so here also we can just increase the quantity of the arrow in element align or grid align as much as we want. Okay, now we can see here that the arrow is in 2D format. Okay, if you want 3D arrows, just click on this option, solid form, and we can see here the arrows is in solid form. Okay, and if we want, we can just change this to line form. Okay, so by this we can just visualize our deformation and other parameters also, whatever we want. But in case of maximum principle or shear, this arrow option does not work because there is no direction here. In total deformation, direction is present, so the arrow option is visible in this. But in case of multiple or maximum strain or stress, we can't see this arrow options opened. Okay. Now there is one more option beside this, that is maximum. It checks a probe that is being placed on the figure, and as we click on it, whatever is the maximum portion of the deformation, wherever the total deformation is maximum, the probe just automatically placed on that face. And just if we click on min, then the probe is being placed on the minimum face. Okay. And if we want to place a probe in between, then just after that we can click on probe option, and wherever we want, see here we can see various values. As soon as we are moving towards the minimum deformation part, the value of total deformation is being decreasing, and wherever we want to place any probe, just click on it, and we can see that a probe is being placed on it, and values also as much as we want we can place it. Okay. So this can be also done. If we want to close this, we can just close the maximum and minimum value. Now in the display sections, if we want to see the whole body, all bodies option is by default present here. If you want to see the scope body, we can just move towards the scope body, and if you want result only, we can just move towards result only body. Okay. So whatever we want, we can just change the option to this. So this I will let you know in other session also in clear border. Okay. So by the help of this, we can just change the visualization of various parameters that is being provided or that we have been given on this portion. Okay.